Okay, the first learning target is about working with exponents. So it's called properties of exponents. You want to keep in mind that you do want to leave all of your final answers so that they have positive exponents. There's more than one way to do some of these things, so I'm going to try to stay consistent in how I explain this stuff. So the first thing is you don't want parentheses. So we're going to go ahead and distribute that -2 into the parentheses. So let me get rid of that. If I distribute the -2 into the parentheses, I'm going to end up with x to the -4, y to the +2nd. Then I'm just going to copy over all of these exponents up here, and then y to the 3rd. Next, I'll fix all of my negative exponents. You can fix a negative exponent by changing its location within that fraction. So if I have this, I guess I'll write all over this so you can see what I'm talking about. If I have this base right here that has this -1, I need to move it down to the bottom. Now this base also has a negative, so I'm going to move that up to the top. So that's going to become x to the +4, and then x to the +1. The other two bases, they have positive exponents already, so we're just going to leave them where they currently are. Okay, and then what we can do is we can simplify them because our final answer should not contain repeat letters. So if you have letters on the top and on the bottom, you can just subtract those exponents. So this problem is going to end up being x to the 3rd, and then I subtract the the exponents on the y's, so that's going to be y to the 1st, and we don't have to write to the 1st power. So that's our final answer. Okay, problem number 2. Problem number 2 is the same kind of deal. I do want to talk about these numbers in the front. These numbers in the front, they just get treated like normal. So that basically says 20 divided by 5. So 20 divided by 5 is 4. So then I'm going to keep everything else. So I'll have x to the -3rd, y to the 5th, and then x to the -7, and then y to the 1st power. Now, I could have moved the x's because you'll notice that those x's, they do have negative exponents. So we could have switched those all in one step, but I'm going to try to be very thorough in showing you like what's happening to everything. So I have the 4 up here, and then the x's, they're going to flip-flop just like in the last question. So x to the +7 ends up on top, x to the +3rd ends up on the bottom, and then we have y to the 5th and y to the 1st at the bottom. So now we can do our subtraction just like the last question. So I'm going to have 4, x to the 7 and x to the 3rd. If I subtract 7 minus 3, that gives me x to the 4th. And then y to the 5th minus y to the 1st gives me y to the 4th also. So that's my final answer. Problem number 3. Problem number 3 has 2 fractions. So you can attack this a couple of different ways. You can fix all of your negative exponents first, or you can just combine it into one big fraction. So I think that's what I'll do. So I'm going to make this one big fraction. So this is 2x to the 3rd, y to the -3rd, x to the -1st. And then at the bottom, since 6 is going to kind of end up in the middle, I'm going to move it out to the front. So it's going to be 6. Then I'll go ahead and unscramble all this stuff too. So 6x to the -2nd, and then y to the +2nd. Next thing I'm going to do is I'm going to go ahead and, I mean, again, there's more than one way to do this. You can combine things that are at the same level. So like if you got those 2 x's on top, you can combine those. So I think that's what I'll do next. Also notice that the 2 and the 6, just like that last problem we did, that can be simplified. So I'm going to have a 3 down here at the bottom. 2 over 6 reduces to 1/3, and then I don't really need the 1 because I've got some letters up there. I don't like seeing these repeat letters, so I'm going to go ahead and combine them. When you see a base repeat, so like in this case, it's the x up here and the x right here. Since those are repeating bases, we have to plus their exponents. So x to the 3rd and x to the -1 becomes x to the 2. And then I'm going to go ahead for right now and just leave that y to the -3rd because I'm only trying to do one step at a time. And then I have x to the -2nd and then y to the 2nd. Now I'm going to also go ahead and fix negative exponents now. So that's going to be my next plan of action. This negative second exponent right here belongs to this x. So that means that has to go up top. So when I move that up top, I'm going to have 3 at the bottom. I'll have the red x squared from before, but then the x to the negative second is going to come up and become x to the positive second. And then I still have that y to the third up there, and then I still have the y to the second down here. Now, if you notice, we've got these two guys right here. Anytime they're at the same level, so both on top, you just add them together. So that's going to give me x to the fourth. And then for the y's, these are on different levels. And they're at the same level, you plus them. So if they're at different levels, you subtract them from top to bottom. So y to the third minus y squared over 3 minus 2 gives me y to the first. And again, I hardly ever write the 1 on there in my final answer. So the only thing left is the 3. So that's my final answer. And then the final question in this section. This one has 2 sets of parentheses, but you do have to follow the PEMDAS stuff. So these parentheses right here, they're telling us to times the 2 problems together. But if you remember PEMDAS has multiply in this spot, but it's got the exponent first. So we have to work on the exponent that's on the outside first. So always take care of your exponents on the outside first. Now, I don't ever write the 1, but I do in this case because I need you to remember that every base has an exponent of 1 when you can't see it. So that 3 is going to distribute and multiply to every exponent on the parentheses. So this is going to become 3 to the third power, y to the sixth power, and then y to the ninth power. So why didn't we plus them is because within this set of parentheses, there's no repeating letters. When the letters repeat, that's when you plus them. There's just the exponent on the outside though, so that's why I didn't plus anything. So now that's still in parentheses, and I don't really like having exponents on my numbers. So if you do 3 to the third in the calculator, 3 to the third, that gives you 27. So this is 27 x to the sixth, y to the ninth. And now we can bring the other parentheses down. So in this parentheses, I'll have 6x to the fifth. That was a weird 5. And then y squared. So now we times the 2 parentheses together. So I have to do 6 times 27. 6 times 27. 6 times 27 is 162. And now because I'm multiplying, because I'm going to multiply, and I have these repeating bases, so the repeating letters, that means I have to plus their exponents. So this is going to become x to the 11th power. Then same thing with the y's. I got y squared and y to the ninth. 2 plus 9 is 11 also, so this is also y to the 11th power. Okay, the next question is where we start to do the stuff with polynomials. So we got to start combining terms and adding and subtracting, multiplying, dividing, and all that good stuff. So in this question right here, we got to clear our parentheses because as you heard in that last section, I don't like to have parentheses. So there's some 1s in the front. When I have a 1 in the front, I just take off the parentheses because 1 times the other stuff is always going to be the other stuff. So I'm going to copy this down. And then I'm going to combine like terms. Now this says to write it in standard form. Standard form means that you start with the highest exponent. So since they want the answer like that, I might as well start searching based off of exponents. So I'm going to put the 1x squared together with the plus 3x squared. So that's going to make, not squared, cubed, oh, sorry. That's going to make 4x cubed. And then I'm going to put together the x squareds. So this is the x squared. And that's the only x squared in the problem, so I can't put it together with anything. And then I'm going to put together the x to the first. And that's the only x to the first in that problem. So I'm going to go ahead and bring that down, including its sign. And then I'm going to put together all the constants. The constants are the numbers without the letters. So I have -8 plus 5 is -3, and then that's my final answer. Okay, next question. The next question is very similar. There's just one tiny difference. Now in this subtraction right here, because that's a -1, when we distribute this -1, we don't just take off the parentheses. what we're going to do is we're going to change every sign that's inside the parentheses. So this positive 5x squared becomes negative 5x squared. Positive 12x becomes negative 12x. And then negative 6 becomes plus 6. The other parentheses, it has a positive 1, so we could just take off those parentheses because that doesn't do anything. And then we combine like terms just like the last problem. So starting with the highest exponent, it's positive 3 and minus 5. So that's minus 2x squared. Then we have the x's. So negative 9 and negative 12 makes negative 21x. And then your constants. Positive 3 and positive 6 makes positive 9. That's my answer. Okay, the next question is way down here. You'll notice now it's times. When we do times, the rules change. That's kind of like the exponent stuff that we talked about in the last section. So this guy right here, it's repeating. So that means you plus the 2 and the 3. So that makes x to the 5th. So it's like you're giving each term an extra 2 x's. So this is negative 3. That was x to the 1st. Now it's getting 2 more. So now it's x to the 3rd. And then this one is just 4. It didn't have any x's, but we're giving it 2 more x's. So it's x squared. And then that's my answer. Next question after that. Now we've got a binomial times a binomial. So this is just the FOIL stuff. It's really just the distributive property. So I multiply these two together first. 4 times 3 is 12, and then x times x is x squared. Then 4x times negative 1 is negative 4x. And positive 7 times 3x is positive 21x. Positive 7 times negative 1 is negative 7, and then we just combine the middle two. So 12x squared plus 17x minus 7 would be your final answer for that question. Okay, this one is very similar. It's just that now it's longer. So I'm going to take this 2x and I'm going to distribute it to all three over here. 2x times x squared is 2x to the 3rd. 2x times x is positive 2x squared. And then 2x times minus 4 is minus 8x. Now when we do this second one, I want to show you guys something pretty cool here. When I do this negative 3 and I distribute it to all three of these guys, because of the way the problem is set up where that shorter binomial is first, I'm going to actually write the answers to this next part underneath based on its like term. So negative 3x squared is negative 3x squared times 3. Negative 3 times x squared just puts them together kind of. And you got the negative 3 times the x, so that's negative 3x. And as you see, like I'm just lining them up by their like terms. And then negative 3 times negative 4 is plus 12. If you really wanted to, you could have had all of this stuff like off to the side, but then you have to go searching. So that's why I like to do these longer problems like this. So now I just put them together. So this is 2x to the 3rd minus x squared minus 11x plus 12. And that's my final answer. Okay, next is a division problem. Now notice this x right here is kind of plain, kind of generic. Doesn't have exponents, doesn't have a number in front. So that means that we can actually use synthetic division. So synthetic division is the shortcut. That means that we don't need any of the letters. So I'm going to put 2, 7, minus 6, and minus 8. And then because this has a, let me get the eraser real quick so I can make this stand out. Because this has a plus 4, when we do synthetic division, we have to use the solution to x plus 4. The solution is negative 4. So I have to make sure to use that on the outside of my synthetic division. Then I could just drop the first term, so it's 2, and then I times them together, so that's negative 8. Combine those, that's negative 1, times them together, and that's positive 4. Combine those, and that's negative 2, and then times those together, and that's positive 8. So that gives me a 0. Now I'm putting the 0 real dark because that's actually the remainder. There is no remainder, so x plus 4 is a factor. And then we want to make sure to put the letters back on. So if you look at the highest exponent in the problem, it was x to the 3rd, so we're going to knock that down by 1, so it's going to become 2x squared. This is going to be minus x minus 2, and then that's my answer. Okay, next problem. The next problem, again, it's got that x that doesn't have anything around it, so that means that I can do synthetic division again. Now in this question, you're going to want to be a little bit more careful when I do my synthetic division. A lot of kids will get this wrong because they'll just throw the numbers in like this, but that's actually incorrect. What needs to happen is you're going to put the 3 here, the -2 here, and then you have to put a 0 right here. And then you can continue. So on this question, now I can just put the 6. So the explanation is based off of the exponents. This right here is the x to the third. This is your x squared, but there is no x. So we have to have a spot for it still. Then this right here is your +1. So I need to use the solution to x plus 1. So that's -1. And now I can do my synthetic division steps. So the algorithm is drop the first one and then times. So that makes -3. Then I combine these. That's -5. And then times again. So that's +5. 0 plus 5 is 5. And then times those again. And that's -5. And then we combine those. And then that's 1. So you can see this last number. That's my remainder. So I need to turn this into a problem with letters again. The highest exponent in the question was x to the third, so I'm just going to drop that down by 1. So this is going to become 3x squared minus 5x plus 5. And then that red 1, that's my remainder, so I'm going to put plus a fraction, and we're going to stick the 1 on top. And then on the bottom, you're always going to stick what you're dividing by. So we're dividing by x plus 1. And then that's our final answer. Okay, and then the last question, you'll notice the last question, it doesn't have just a regular old x. Now it's got a 2 in front, so we're not going to use synthetic division anymore. We actually have to use long division. So 6x squared minus 13x plus 6, and then 2x minus 3. So if you remember the algorithm that I gave you in class, it's going to be the first one from the inside. So 6x squared is the first one inside, and we're going to put it on top of the first one from the outside. I was calling that the stacking step. So 6x squared over 2x would give me 3x. And then I'll stick my 3x right above its like term. So I'm going to stick 3x right here. Every time you put something on top, you have to go back and times it to what you're dividing by. So 3x times 2x is 6x squared. And then 3x times minus 3 is minus 9x. Now in my algorithm, after you times, then you have to go through and change all of your signs. So this becomes a minus and this becomes a plus. And then we put them together and the whole process starts over again. So if I combine these, that's -4x, and then I can drop this down. So -4x plus 6. So now what I'm going to do is I'm going to take the first one from the inside, and again, I'm going to put it on top of the first one from the outside. So I'm going to stack them. So I have -4x all over 2x. These x's cross out, so I'm just left with -2. So I'll put a -2 up here. Every time you put something on top, it has to multiply to 2x minus 3. So -2 times 2x is -4x. -2 times -3 is +6. After you times, then you change the signs. So I put that as a plus, and I'll put that as a minus. That crosses out, and then that's 0. So because that's 0, that right there means that this divided evenly. So that's my answer up there on the top with no remainder. Okay, the next one says, write a polynomial that represents the area. Now what you have to remember about the area of a box is anytime you find the area in geometry is just base times height or length times width, whatever you want to call it. I'll call this length times width. So the length is going to be this longer one, and then the width is going to be this one. So they want us to find the area, so area is just to multiply. So it's length times width, and then we just multiply it out. So 2x times x is 2x squared. 2x times +3 is +6x. -1 times x is -1x. And then -1 times +3 is -3. Then we put together our like terms. This is going to give me a +5x with the -3 at the end, and then a 2x squared at the front. Yeah, they didn't give us units, but if it would have said feet, we would have put like feet squared, because then it would have been feet times feet. If you have a really picky teacher, they might mark you wrong for not doing this, so we'll just say square units. Me, I don't really care. I'm not here to see if you know how to multiply units. I want to see if you can multiply the actual stuff. Okay, next. Remainder and factor theorem. This one, this section has some of the answers that you need to write at the top. Like it's called the remainder and the factor theorem. Those are actually some of your answers. So the first one says, according to the remainder theorem, if you calculate f of c, what does that tell you about x minus c in the polynomial? So I want to talk about real quick, when f of c gives you 0, that's actually a good thing. So that's telling us that it has a remainder of 0. So that means that x minus c is a factor. Anytime you have a remainder of 0, that means that it divided evenly. So that means that it is a factor. So that's just kind of something you have to remember. If it gives you equal 0, that means that it is a factor. And if it doesn't give you equal 0, that means that it's not a factor. Okay, next it says, for each of the following, use the remainder theorem to evaluate that problem. So basically they want us to plug in some values in here. So I'm just going to write this part once. I'm going to write the entire problem, but I'm going to write it without its x's, because we're going to be substituting in those x's. Oops, that's actually 28, and then parentheses, and then minus 20. So the first one they want us to check is 4. So we go in and we put 4's all in here, and then this can all go into the calculator. So in the calculator, it's going to be parentheses 4 to the third power, and then it's going to be minus 7 parentheses 4 squared minus 28 parentheses 4, and then minus 20. So this one is saying for each of the following, evaluate. Evaluate means just to plug it in and get the answer. So my answer to this problem is negative 180. And then I'd have to do it 2 more times. So the nice thing about the calculator is we don't have to redo it all. So all we have to do is kind of delete all the 4's and then put in the next number they want us to test. So they want us to test 0. And I'm not actually going to plug this one into the calculator, because anytime you plug in 0, it basically just makes all of that stuff go away. So the final answer is going to be the last number, so it's going to be negative 20. So this equals negative 20. Then I'm going to erase all of this. If I actually did type it into the calculator, now I'll show you that part. So now they want us to try negative 2. So if I put in negative 2, negative 2, and negative 2, here's what that means. If I go into my calculator, I'm going to go up to the problem and highlight it. Then I'm just going to scroll back, delete, and stick a negative 2 in there. So every parentheses gets deleted on the inside and replaced with negative 2. So delete negative 2. And the answer is 0. Now that part right there is super important. So we'll talk about all that stuff in number 16. It says, what conclusion can be made from the results of 15? So first of all, I just want to make sure this is clear. This is called the remainder theorem on this problem. Remainder. And this one is also called the remainder theorem. Remainder. And then this one right here is called the factor theorem. So the name of the theorem is based off of the results. If the result gives you 0, it's the factor theorem. If it doesn't give you 0, then it's the remainder theorem. So number 16 says, what conclusion can be made from the results of 15? So here's what we know. Since they tested 4, we know that that came from x minus 4. And since the answer is negative 180, we're going to say that it is not a factor. Same thing with this guy right here. If it's 0, that just means x, because I can't put the opposite of 0. And because the answer was negative 20, we're also going to say that it was not a factor. And then finally, the most important one is this guy right here. So because we tested negative 2, that means it came from x plus 2. And then we say that it is a factor. So you can tell if it's a factor based on the result. You can tell the name of the theorem based on the result. If it's 0, it's the factor theorem, and that means that it is a factor. And if it's not 0, then it's the remainder theorem, and that means that it's not a factor. Okay, it says if x plus 5 is a factor of that problem, find all of the other factors. So this one actually isn't that bad because they gave us a nice simple x. If it's a factor, that means that I can use synthetic division to divide it. And because we're doing synthetic division and they're saying that it is a factor, we know that the final part of this is going to end up being a 0. So I'll show you that here in a second. So here's what I'm telling you. They're saying that it is a factor, so I promise you this last number is going to be 0 when we do all the work. So here's the first step. We drop it, and then we times it. We combine it, and then we times it. What is that? Plus 15. And you want to make sure that your math is right. So even on the simple stuff, make sure you're typing it in to double check. One miscalculation will throw this whole thing off. So if I do that, it's going to give me negative 18. If I do negative 18 times negative 5, that gives us positive 90. And just as promised, I told you that was going to happen, and we knew that was going to happen because it's saying that it is a factor. Okay, so here's what this means. This problem, because we did synthetic division, is now x squared minus 3, x minus 18. And if we want to find all of the other factors, all we have to do is factor this one. Now this one is a simple not a simple GCF, it's a simple ABC. So you can either find numbers that multiply to 18 but add to 3, or you can use the life hack that we learned a long time ago. I can go into my solver. I'll do the polynomial solver, degree 2, and I'll stick in 1, negative 3, and negative 18. Now be very careful because these are answers, and answers are the opposite sign of your factors. So if that says positive 6, that means over here it has to be a minus 6. And if the other one says minus 3, that means in here it's got to be a plus 3. Those are your final answers. This one is, it's almost pretty much the same thing. So I'm going to do the same exact process again. So I'm going to do 2, 1, negative 2, and negative 1. And I don't need any zeros here because all of these exponents are accounted for. And then they say x minus 1 is a factor. So that means over here I'm going to stick plus 1. And we do the whole process over again. Drop that, that's 2, times that, that's 2. Combine that, and that's 3, times that, and that's 3. Combine that, and that's 1, times that, and then that's positive 1. So again, we knew this was going to work. We knew that last number was going to be a 0 because they're saying that it is a factor. So now we need to see what this problem looks like. This problem now looks like 2x squared plus 3x plus 1. And then again, we can just use the solver. So I'm going to put 2, and then I'm going to put 3, and then I'm going to put 1. So I'm going to get my answers here, and we'll talk about fraction answers here in a minute. So it gives me a fraction of negative 1/2. And because it's a negative 1/2, I got to remember to switch this to a plus because factors and answers are always opposite. The second answer is negative 1, so that means I got to stick in a plus 1 right here. Now you're not allowed to leave your final answer with fractions, so that's when we do that move that we call bottoms up. So this bottom has to move up to the front of this x. So this becomes 2x plus 1, and the other one is just x plus 1. So that's our answers. Last two factors. Okay, next, what is the minimum degree of a function that has 4 real zeros? So the degree is the highest exponent, and if it has 4 real zeros, that means that the degree has to be at least 4 or higher. Okay, next, what are the zeros of the function? Now this one is very nice because they actually factor it for us. So if you have the factors, you can just solve each of those factors. So if I solve each one of these by setting them equal to 0, all the signs flip. So one of them is going to be at positive 1, one of them is going to be at negative 2, one of them is going to be at Oh, I forgot to put the equal sign. Let me erase that and write that a little better. So that one's going to be at -2. This one's going to be at +3, and that one's going to be at -4. And it's because when you set them equal to 0, the math you have to do to get rid of the +4 is you -4. So all that happens is the signs change. So there's our 4 answers. Okay, number 21, it says, what are the zeros of this one? Now these ones still have exponents, so we're going to have to solve them just a little different. We're going to have to set each one equal to 0 because they're squares. If they were higher than squares, we would have to factor them down so that they're lower. So I'm going to solve this one by adding 25 to both sides. So this is x squared equals 25. And then I just square root it. And this is going to give me x equals plus or minus 5. I do that for the other side, x squared plus 16. I'm going to minus 16 to both sides. So x squared equals minus 16. Then when I square root this side, you're going to have to be kind of careful because that negative, we learned about that before, that negative gets fixed because it turns into the letter I. So you'll have plus or minus with an I on your answer, and then the regular 16, if you take the square root of 16, is 4. This problem, if you times it out, is an x to the 4th problem. So these answers right here count as 4 answers. So you have positive 5, negative 5, positive 4i, and negative 4i. And you don't have to separate them. I was just writing them out so you could see that it actually is 4 answers. Okay, next it says find all the zeros of the following functions. So what I'm going to do here is I'm going to go over to the calculator, and you can also use Desmos for this. We talked about this in class. So I'm going to go over to the graph, and I am going to delete that because I don't even know what that is. And I'm just going to type in the graph. So x to the 3rd, and then minus 8x squared plus x minus 8. Now let me go ahead and change the viewing window. So my viewing window gives me a graph that looks kind of like this. It goes down, oh, get out of the eraser. It goes like this, and then it comes back up. And it looks like it only touches the x-axis one time. But I can use the gsolve to go find a root. So that right there tells us that one of the answers is x equals 8. So here's the nice thing about that. If x equals 8, that means that we can use synthetic division to lower down the exponent. So this is going to be x squared. Oh, I forgot. We're doing synthetic division. Synthetic division doesn't use any letters. So 1, -8, and then 1 and -8. So we're going to drop down the first number. So that's 1. I'm going to multiply that, and that's minus 16. And then I'm going to, what am I going to do? Combine those, and that's, what is that? Minus 8. Just making sure. Hang on a second. Double checking some stuff. Let me make sure I type this in right. So x squared minus 8x squared plus x minus 8. So hang on a second. Something looks fishy first. Oh, I put in the 16. That's not a 16. It's crazy talk. Okay, here we go. So now, if I times 1 times -8, that gives me -8, which is also kind of fishy. And we drop these, and that's -16. And what's happening here? This is looking weird. 20, what is that? Oh, hang on a second. I'm going to take a quick break and make sure that I'm doing this guy right. Hang on a second. Okay, I'm back. I went to go get myself a drink, and I realized that I must have been having a brain fart there. But I figured out what I was doing wrong. And this is good that it happened so we can talk about it. So, remember that the answer that we found was x equals 8 right here. When you do synthetic division, you don't put a -8, you put a +8. So you don't change the sign of an answer when you do it in synthetic division. So that's where I went wrong. So that was my bad. Gotta start paying attention to small details like that. Now this should work. Okay, so we drop this first one, and that gives me 1. 1 times 8 is 8, and now this gives me 0. And then this right here, when we multiply that, gives me 0. 1 and 0 makes 1, and then 1 times 8 makes positive 8. Now we're in business. So I knew something was going horribly wrong when this wasn't going to give me the 0 that I needed. So here's what happens. This exponent dropped down from a, get this out of the way, x to the third. So now it's x squared plus 0x plus 1 equals 0 because we need to solve it. So I'm going to subtract 1 from both sides. So we have x squared equals -1. We're going to square root it, and that should give us 2 more answers. So we're going to get plus or minus square root of -1. The negative right there becomes the letter I, and then the square root of 1 is just 1, so it's plus or minus I. So there's a total of 3 answers. There's x equals 8, and then the other 2 are going to be I and -I. Okay, next question is, what is this? 23, find all the zeros of the following functions. Okay, so this guy right here, how can we do this one? This one is a, what do you call it? Cubes problem. So we can actually factor this one. I know it's a cubes because it's got 2 of them, and this is a cube, which can be cube rooted, and so can 27. So this guy right here, this is just going to be x, and then this one over here, this one is just going to be 3. So using the formula AB, AA, AB, BB, all we have to do is follow this format. So A times A would be x times x, so this is x squared. And then A times B would be x times 3, so that's going to be 3x. And then B times B would be 3 times 3, so that's going to be 9. And then we use the SOAP acronym. So S stands for the same, O is opposite, and then AP is always positive. Then what we can do is we can set these equal to 0 and solve it. So that's going to give me x equals 3. Now this guy right here, this is my real solution. I wonder if they asked for real only. No, this one says find all the reals, or all the zeros. Well, I'm going to use this to show you guys something. So in this problem right here, if it said only find the reals, this answer right here would be the only answer, because this part over here never works. It never factors nicely. So this one right here, chances are it's going to give us i's, and I can show you in the solver. Let me go over to the solver menu. I'll go into my equation solver, and I know it's not going to work because there's not 2 numbers that multiply to 9 and add to 3. So check this out. Go into the polynomial solver, degree 2, and I'll stick in a 1, a 3, and then the positive 9. And when we solve that, see, it's going to give us an answer that has i's in them. So if they ask you for an answer that is real answers only, we would not include this fraction with these i's on them. And that's how I'm going to teach that problem. Okay, so the next thing we have to do is we have to graph this and find all the information from it. So from the parentheses themselves, we can actually find the x-intercepts. If it says x minus 4, that means that this right here is going to have a dot at plus 4. If that says x plus 3, that means there's going to be a dot at minus 3. And then plus 6 would have a dot at minus 6. So if they ask us for the roots, those are actually the roots. See if they ask us. Yeah, they do ask us. So the answers for the roots are going to be at -6, 0, -3, 0, and +4, 0. Okay, now for the rest of the picture, there's only a few things that I can do without actually having the answer here. So what I could tell you is, let's see, there's 3 x's here, so that tells me that it's x to the third. And every x to the third graph usually goes left side, hold on a second. The x to the third graphs usually go left side down and right side up. But because of this minus here, that's going to flip it. So if that flips, that means the left side is up and the right side is down. So I can actually do the end behavior without even seeing the picture. If the left side is going up, that's going to be a positive infinity. And if the right side is going down, that's going to be a negative infinity. Now, another thing to note is any x to the third graph, anytime it's an odd exponent, your domain and range will always be negative infinity to infinity. So that goes for both the domain and the range. So basically every number gets covered by this graph. It goes left forever, right forever, down forever, and up forever. See if there's anything else we can find. Now for the rest of it, we're going to actually need to use either a graphing calculator or you can use Desmos. So I'll just use the graphing calculator since that's what I have here ready to go. So I'm going to go over to the graph. I'm going to delete this guy. And then I'm going to even type it exactly how it looks. So negative parentheses x minus 4. And then parentheses x plus 3. Make sure to put that plus sign in between. And then parentheses x plus 6. So this kind of goes off the charts, so that's probably not the best graph I've ever seen. So let's go find some stuff. So we already know this graph's going to go up like this, because that's what that graph is showing me on the calculator. We know over here it's going to go like this. So what we don't know is how high it's going to go, and that's kind of important. So I'm going to use my Gsolve button to find the maximum. So see right there where it says max on F2. So this is telling me that my maximum is located at 1.29 and 84.7. So this goes off the charts. This is the worst graph they could have probably given you for this question. So it goes off the charts like this, and then even down at the bottom, let's see what the minimum is. So let me go back to the Gsolve minimum. Yeah, the minimum is at negative 19, so that goes off the charts way down here. So this is, whoever made this one wasn't thinking ahead. And my computer's freezing, so let's see what's going on here. Okay, there we go. So this graph, not the best graph to use. Hang on a second. My freezing for some reason. There we go. Okay, now we're in business. On a second. I don't know what's happening. The touch screen isn't working, so I'm going to pause this so I don't. Okay, so it seems like my little stylus pen thing died, but this graph goes way, way down like this and way, way down like this. So I'm just going to kind of list what the maximum and minimum are. So the minimum was, so I'm going to write like this, min was negative 4 point, what was that? I forgot. Negative 4.6, comma, and then we'll just go to the nearest tenth, so negative 19.3. And then the top, the maximum, that one was going to be at, Gsolve again, maximum, 1.3 and 84.8. So 1.3, 84.8. Now here's the reason why I'm marking those numbers. You can actually come up with the increasing and decreasing intervals because they're going to go all the way to these x values and then change directions. So the first one, this guy right here, is going to be decreasing all the way up until it gets to negative 4.6. So it's going to be decreasing from negative infinity to negative 4.6. And then the other decreasing is going to be coming from right here, and it's going to be going down like this forever. And that's going to start from 1.3. So I'll put union 1.3 to infinity. And the reason why that's positive infinity is because we're doing it off the x-axis. So this is why it's negative infinity over here and positive infinity on the right. In between right here, this graph is headed up. So it's going up from 4.6 to 1.3. So negative 4.6 to positive 1.3 is our increasing interval. I don't know if they asked us. Did they ask us for a max and a min? No, they didn't ask us. Oh, here. They want to find the average rate of change between the maximum and the minimum. So we're going to have to do y2 minus y1 over x2 minus x1. Our maximum, or I'll start with the minimum. The minimum was first, so x1, y1. And then this is going to be x2, y2. So according to that formula, it's going to be 84.8 minus, put these in parentheses, negative 19.3. And then at the bottom, see, it's going to be, what do we do first? 84.8 and 1.3 minus negative 4.6. So that all just goes in the calculator. So we'll go to the regular menu, delete all that, it's ugly, parentheses, or ABC. So we got 84.8 minus negative 19.3. And then we're going to have 1.3 minus, come on, minus sign, work with me, negative 4.6. So that answer is 17.6. That's my answer. Okay, the last section is all review. So I'll just whip through this real quick because I know this video is getting way too long. So this is going to be 15 minus 35i. Then we multiply these, and that's going to be plus 9i. And then that's going to be minus 21. And then we have this I squared. Now this I squared, it basically becomes a negative 1. So that makes this over here a plus 21. So that turns it into a plus, which you can now put together with your 15. And you put these guys together. So you have negative 35 plus 9. 35 plus 9. And these have i's on them. So that's negative 26i. And then you're going to put together the 15 and 21. 15 plus 21 is 36 minus 26i. And then our life hack can actually do the entire problem in the calculator when they have i's in them. So let's move this over. So if we were to do it, it could be 5 plus 3. I is shift 0. And then you're going to have 3 minus 7i. Shift 0. Shift 0. And you get the same answer. Okay, next, find the x-intercepts. There's more than one way to do this. The x-intercepts are the roots, so you could either look at the graph and see where it crosses the x-axis, or you could just solve this. 4x squared, 4x squared minus 16 equals 0. So if you add 16 to both sides, you get 4x squared equals 16, and then you divide by 4. You get x squared equals 4. Square root, and you get x equals plus or minus 2. So you could also look at the graph. If you were to look at the graph, it's going to cross right here at negative 2, and it's going to cross over here at positive 2. You could also factor that. If you factor out the GCF, you would have 4x squared minus 4, and then that's a difference of squares, so you could have x plus 2, x minus 2, and then you just solve the parentheses. So x equals negative 2 and x equals positive 2. So either way, there's like 3 different ways you can come up with the same answer, and they all do the same thing. Next one is factor. So you want to factor this simple ABC, two numbers that multiply to 21. So 1 and 21, 3 and 7. That's the entire list. The list is actually very short. We want to make a 4. So the only one that can make a 4 is a 3 and a 7. To make it a plus 4, though, would have to be minus 3 and plus 7. So minus 3 and plus 7 is the answer. And remember, they're saying factor, not solve, so we're not going to flip the signs. Could also use the solver, but if you use the solver, it'll tell you x equals 3 and x equals minus 7. Or again, you can look at the graph. If you looked at the graph, it would cross at x equals positive 3, and this dot right here would be at x equals minus 7. And I'm showing you all this stuff because at this point, we're just putting it all together now. You find the answers, but remember, answers and factors are opposite signs. So when you find that x equals positive 3, you have to make sure to put it as a negative 3 in your parentheses. And then finally, the last one is solve for that weird symbol. I don't know how to say it, so I'm just going to solve for it, whatever it is, because it really doesn't matter. So I want to try to get that by itself. So I can't have parentheses, so we can just kind of pretend it's like an x. So I need to get all those to one side, so I'm going to subtract 5 with that weird thing. So minus 5 with that weird thing. So these cross out, so that's negative 1 with the weird thing. Minus 9 equals 25, and then we have to add 9 to both sides. So that gives me 34 equals negative 1 with the weird thing. And then just divide by negative 1. So the weird thing equals negative 34. Now that was the longest video ever, longest review ever, but the test is not going to be that long, so don't panic. You should have plenty of time to finish it in one class period.